And I'll just say a couple of words very quickly before handing over to you, Tomoya. So, hi everyone, welcome to the Cloud Robotics Working Group. Welcome to those who have been here before, welcome back. And to those who haven't been here before, welcome. We're a group that are trying to make cloud robotics better. We're looking at what's going on in the industry, and we're trying to put together resources, tutorials, and eventually maybe even write some code is the plan. So to that end, we've created the Cloud Robotics Hub, which we've got a blog where we can write some blog posts. For instance, we had a talk on Eclipse Xeno, and then one of our members, Phil, wrote up a blog on switching to Xeno, which was really cool. Thank you for doing that. We list all the meetings that are coming up. We have our State of Cloud Robotics survey. So we sent out a survey that was public and got some results from that. So if you're looking at what the industry in general thinks of cloud robotics, please do take a look there. And finally, our resources, where we try and list all the resources that we have for different categories. There's a few, there's not too many at the moment. If you want to suggest some, please do go ahead. There's a link here on the forward. Please create an issue, and then a couple of other pages. So I'll post the link for that in the chat. And otherwise, that's all I wanted to say. And I will hand over to you, Tomoya, if you're ready to go.
Yeah, I'm good to go.
Great. I will let you speak in that case. And thank you for coming to talk to us.
Do you see what I see?
Yeah.
Browser. You see that?
Exactly. Yeah.
Okay. Yeah. So thank you very much for having me. And I'm Tomoya. I work with Sony, and I'm gonna talk about probably this talk is not gonna be only for the cloud, but it's more like how to bring the CNCF technologies to the edge. So during the presentation, the problem statement and what we are trying to do is actually to address the edge situation. And the presentation slides and the GitHub project, everything is published. So just click there, you can take a look. So the first one is actually this presentation is what I did the last year, the ROSCON 2023, about the ROS and ROS2, how we want to use the Kubernetes and KubeEdge. So I'm going to pick up some contents, and also there is another slide that I did last month at the KubeCon about the container network interfaces. That's also related to solve the network solution. So I'm going to pick up some ideas from here, and then we can go on the next slide. And you can stop me whenever you want. This is a casual presentation. Just want to share the experience, and I want to really have the feedback from you. So I'm going to skip this page. So some background. So at the edge, especially robotics situation, we have the broad use cases. And this is not only for the robot application, but it's, for example, like a Sony use case is entertainment, EV, live streaming, some other edge devices. These are really complicated to address. And also the systems are not anymore like a single system. It is connected and distributed. For example, like at the factory logistics, that we have robots working together for highly task, doing some collaboration with low latency. So that's what we are looking at it. And once it comes to the edge AI related application, we need to redeploy the application with the retrained network every day. So that requires us to redeploy the application committally or hourly once we have something new. And that new network and bound to the application needs to be pushed down to the edge probably every day. So that's the situation we have. And also the edge, like it's not cloud, but the edge is we have like a bunch of sensors, proprietary hardwares, acceleration that we have. So it's more complicated. and also how we want to deal with the network situation, how you want to go over the NAT, or how you want to connect to the cloud instances. That's always a problem for the edge. So in one picture, we have something like this, right? So I don't know if you have the same situation, but we have like 1,000 robots at the site, and at the same time we have many instances running in the cloud, and then we need to manage all these instances all together. So that's the situation I'm talking about. So the pain, what's the pain is the platform dependency. We just want to more the flexible management, and we want to conceal the hardware so that the application can be agnostic from the platform. That's what we really want to do. And at the same time, we want to have the platform specific acceleration for the container. So the question is how we want to access the host system acceleration. And I think third one is most important, application modularity. So the application engineer can spend 100 time of the application logic, not the infrastructure, not the network, not the storage, just want to spend the time 100% on the application. I think that's the important thing for the business. And I would say the next one is the network bridge. So I think this is sometimes during ROS community, specific implementation introduces some bridge or proxy, but this is kind of strong opinion, but I think it doesn't make sense, because if you use the specific bridge for the specific application framework or transport layer, you need to deal with every single one of them. That means if you change from framework A to B, you need to deal with a new bridge, right? Or if they don't have the bridge, the proxy, you need to develop by yourself, or I mean, like a open source cooperation or whatever. But that's the situation for what you have if you have like an application specific bridge. But I think, in my opinion, the network problem should be addressed by the network layer, so that application can be 100% agnostic from the network. So in other words, I think application should say, give me something I can connect in secure. That's it. That's all it is. If that's the network problem, that should be addressed by the network layer. That's the, I think, most important point. I think I already told about this, so I'm going to skip this. So to, we are working on to address these kind of issues with Kubernetes, because we see, I wouldn't say the perfect, but 80% of our requirement can be covered by Kubernetes. For example, application deployment orchestration, and device capability control, and label control, and auto scaling, scale up and down, canary test, and role-based access control, and also device plugging, which is, I'm going to explain that later. So including container network interfaces. And the Kubernetes is okay. It just works. I mean, we do, right? We do use the Kubernetes in the cloud infrastructure, and that's fine. But how we can address the edge situation, which is that maybe the network is not stable, and there are many hardwares and devices, and most importantly, if you run Kubernetes, there's going to be the kubelet, which is the agent running on your edge device, and that consumes your CPU resources. And let's say that is a tax, and how much tax can you pay? Does it really pay off our business? So that's exactly where the Kubernetes comes in play, and that's really resource efficient. We tried the Raspberry Pi 4, and the CPU consumption is pretty low. You can't even see that. And also the Kubernetes provides cloud edge coordination using WebSocket or the Quick that you want to configure. That means you can connect the control plane to the Kubernetes cluster running in the cloud infrastructure, and also provide edge autonomy. That means if the connection goes offline, I mean, your control plane connection is if go offline, that's fine. The Kubernetes still running in the edge situation, it keeps the container running, and once the network comes back online, everything is going to be resynchronized altogether. So that's where exactly the Kubernetes comes in play. So this there is the GitHub repository here. So this is a project, my kind of personal project to explain about. This is pretty much about documentation and examples how you want how we can deploy ROS and ROS2 using Kubernetes or Kubedge. So if you are interested, there are many examples and explanation there. So if you're interested, you can just take a look, and all you have to do is set up Kubernetes, and then just call the kube apply to you can try the ROS one, either ROS one or ROS two deployment. So I'm gonna pick up some maybe ROS one just a bit. I don't know if you guys use ROS one. So if you click on that, it's gonna jump to this GitHub project, which explains everything. So in this case, the ROS one example. So ROS one, we need to have ROS master, which is kind of like a server running in the ROS network. And usually what we do on Edge is like we bind a specific IP and port number, and then all the other application that make sure set it on the environment variable to access to the ROS master. That's how it works. But on Kubernetes, we can use the DNS discovery provided by the Kubernetes. So actually, this ROS master can be running anywhere and expose that hey, you can connect me using this DNS name, and then everybody else can connect this ROS master. So just an example, you can click here. You can see the entire deployment configuration. So yeah, something like this. It's really complicated, so I'm not going to explain, but this is the header service provided by Kubernetes. So it's gonna create the service, and the backend pod is bound to this service and expose that service name to the DNS, so that everybody else can DNS the name to this ROS master server or something like this. These kind of like examples. This one is ROS one. Oh, this one is using ROS localhost. I think this is going to be useful for the isolation environment. For example, like if you want to provide the isolation environment for the ROS2 for each student or something. So this is example how to use localhost in the Kubernetes. And also, if you want to configure, sometimes you want to configure some specific ROS2 network that you can do using config map. That's one of the custom resource provided by Kubernetes. And all you have to do is describe whatever you want. This deployment goes to ROS domain ID XYZ, and then the bound to the configuration map to the application. So the application doesn't have any idea about this configuration. Because you can bind any configuration to any container logics at the runtime. So that's really useful to manage the configuration data and application logic isolated. And sometimes I think this one comes from the question that I had before, how you want to use GUI-based application, for example, a TotalCM or RQT, that if you want to use Kubernetes, you can do that. It's just about how you want to bind those how you want to access the from the container to the host system devices, which is display in this particular case, that you can do that. So example is there. Yeah. So last thing I want to talk about here is device abstraction. So as I mentioned, there are many devices at the edge, but we can use the device plugin, which is we already have confirmed to access from the host system, from the container to the host system devices. For example, like a DSP or FPGA. We have some system service application to manage the host system services, so you can access the application manager hey, I want to use this specific API provided by host system, that you can do that. So the device plugin is one of the custom resource, but you need to implement the logics as the implementation. But as far as we find, this is really useful to expose your platform-specific devices and maybe the API provided by the host system. This is really useful. Yeah, so this is the security, how you want to security data to the application. So in my opinion, the security information and the application logic should be separated, because I think if you're working on security data, there's a guy. Sounds like the business specific logic, right? So, but the application logic should be agnostic from the business logic. So, what we can do with Kubernetes is we can take advantage of the configuration map. So we can describe how we want to secure the ROS2 network using configuration map as a first step, and then bind those security data to the application logic. So they are totally separated, but we can bind it at the same time, at the runtime when we start the container. I think that's really useful to manage security data and application logic. So application logic perspective, they just develop the application, and then we can say, hey, use this configuration map, and everything is secured. That's how it works with using Kubernetes. Yeah. And do we have any questions? You can stop me if you want. I'm just talking by myself. So if you don't have any questions, I'm going to go next slide. Is everything okay?
Yeah, everything's good, thank you. If anyone
Okay.
does have a question, please go ahead and raise their hand, and then Tomoya can keep an eye out for that, or I can shout if I see it as well.
Yeah. So the next slide is actually come from the KubeCon that took place last month, North America. So I have been working with Cilium and KubeEdge. Cilium is one of the container network interfaces and implementation, and it's kind of like a default standard for now. Cilium provides WireGuard-based VPN and also encryption and container network interfaces, and also the security runtime enforcement, which calls Tetragon. I'm not going to go details of Cilium, but this talk is dedicated to how we want to solve the network problem between cloud and edge, or cross-edge communication. This is really interesting. I'm really excited about this activity, because that's going to be something really useful for the edge situation. Okay, let's go. I'm gonna skip this one. Oh, by the way, if you are interested in CNCF Cloud Robotics perspective, I have some couple of papers, white papers, edge native application design behaviors working. I worked with other members, for example, VMware, Red Hat, Cisco, these guys. So we put something together as the principles. So if you're interested, please take a look. And edge situation. I have already explained this, so I'm going to skip this. And this one's okay. This one's also same. And I'm going to. I just want to talk, just to point out. So Kubernetes, there is the container network interfaces. So this presentation is dedicated to the Cilium. So yeah, just move on. Sorry. So I already explained about KubeEdge, but on this page, I want to say, if we use KubeEdge, so having Kubernetes cluster and the KubeEdge, you can collect the control plane as cluster management. You can do, right. So that's fine. But the question still stays, how we want to manage the data plane. For example, your application is running at the edge server, and let's say that's a ROS application, and at the same time, you have some simulation or some like intelligent process running in the cloud instances. And if you want to connect those ROS application without any extra operation from the application developer, the connectivity needs to be established, right? Uh, Otherwise, you need to have the bridges that I don't like. Uh, so, so to address that specific situation, I just want to say that if we use the kube edge, there was we could not use any CNI before. That means we cannot bind any container network interfaces if we use kube edge. That was the pain for us, and we need to fix that. So now the kube edge can enable the Cilium at the runtime container network interfaces. So that means you use Kubernetes with Cilium container network interfaces. That's fine in the cloud, and also you can deploy the kube edge to your edge device, and the controller plane is connected using MTLS and using either WebSocket or QUIC. That's fine, and also the data plane can be connected using Cilium because we can now enable the Cilium on the edge. So this is pretty new. So we have fixed the bunch of issues, kube edge. I'm not gonna say details, but most likely, we what we did is fix the bunch of problems about in-cluster configuration, the code by the kube edge to the Kubernetes. That means we can do something like this. The application developer does not do anything, right? So we just provision device or cloud instances. We enable class Kubernetes on the cloud, and we enable kube edge on the edge device over the internet. And the controller plane, we have the secure connectivity. And also the data plane is established using Cilium and WireGuard VPN. So once the provision is completed, you have every we pretty much you have pretty much everything. Everybody is equal, and you can deploy your application anywhere you want, and it is already secured connection using WireGuard VPN. So that's pretty good because all you have to do is you make this decision how you want to deploy the ROS application. No bridge, no required. So you just have a go. But there's one constraint using the WireGuard VPN. So the WireGuard VPN is enabled by the Cilium, and but currently the only topology we can support is P2P. So that expects all the nodes should be connected in the hardware physical layer. So for example, something we can't do right now at this moment is cross-edge communication. For example, if you have the home device and also I have the home device. Let's say we want to connect these these robots together using this solution, but we can't do that because the WireGuard connects all the peers as P2P topology. So that's something we can't do. But what we are working on is, can we get some information from the Kubernetes cluster for the node information, and then we can create the topology based on some labels. For example, like hub and spoke topology. It's like a client server architecture, or the point to site or site to site. If we can have this kind of a flexibility using this solution, that everything can be connected using this dynamic topology changing or something based on the WireGuard. And the WireGuard requires only the Linux kernel, and that's kind of like legacy configuration. So as long as your device is running Linux, we can enable Cilium and also the WireGuard VPN at the same time. And once the class is set up, everything is there. All you have to do is just write down how you want to, how you want to deploy the application and how you want to connect. And also, you can have the full support for the cloud infrastructure as we do right now. So that's the I think this is going to be something really interesting because for the next generation architecture for the edge. Yeah, the last thing I want to say is this is not just the idea. We already have developed the POC code, and I also have discussion with Cilium community. They are also interested in the robotics use cases, because if we can make it, there's going to be like 1 million devices that we have. So I'm going to work with the Cilium, the maintainers, to develop this feature for CNCF project. So I think that's all we have today. I would like to have the questions. Yes.
Thank you, Tomoya. Wonderful. I was wondering, because I have a pretty similar setup with WireGuard, and I also ended up using peer-to-peer, but the problem was really with WireGuard, the fact that I could only associate a multicast address to one peer. Is this the reason why you have also this peer-to-peer topology, or is it a different reason?
So if we use this solution, we don't expect to use the multicast. Yeah, that's the first thing. Because
so how do you do discovery then in ROS2?
Okay, that's a good question. I already have the example. Discovery. There should be somewhere ROS2 fastidious discovery. Okay. So if we use this solution, that actually we don't use multicast because it generates lots of packets in the cluster. We don't like that, right? So everybody going to be affected. So instead of doing that, what we do right now is using fastidious discovery, because we do use fastidious. If you want to use the other implementation, I think they should have some discovery implementation or something. But what we do right now is you taking advantage of the Kubernetes DNS discovery framework. So what we do is we create fastidious discovery, including backup as a service, so that everybody in this cluster, including edge devices, anywhere your ROS application is running, it can DNS where exactly access this service endpoint, and including a backup server. So it's reliable.
But then you're basically doing unicast in the end. So you're
yeah.
If I am sending my camera stream from one robot and I have two subscribers, actually I will have to do unicast twice, basically.
Oh, are you saying? I thought you were saying the question about the discovery, not the data plane, right?
Yeah. Okay. Yeah. Because I'm mixing. I mean, we're using multicast for both, right? I'm also using multicast for delivering packets in.
Oh, okay. So
in ROS2.
Oh, okay. So you were talking about like a data plane, right?
Yeah. Both, actually. The problem is multicast per se. That's why DDS was so much trouble, because it uses multicast both for discovery, but also if you can, to just send one packet to multiple recipients. So like the camera stream, for instance.
Yeah, but in the cluster, what we see is there are many devices, right? And cloud instances. Usually, what we do is we don't use the multicast-based solution, because I mean that's going to generate that's really intentionally. For example, some container network interfaces, they disable the multicast on purpose because of this problem. So usually
inside the cloud, yes.
Yeah.
That's why there's no somehow there's no nice ingress that you could use to send to a single endpoint of a Kubernetes cluster and then make this camera stream go to multiple endpoints just by sending it once, or did you find a solution for that?
Actually, if you want to use the multicast, you can. Let's see. There's container network interfaces. I think if you want to use multicast, you can, because multicast. So if you use Cilium as container network interfaces, you can use multicast. That's pretty new feature, because we were pushing this feature to the Cilium community, and we also provide some CLI to enable what is a multicast group and what is the IP address that you want to configure for the Cilium. So you just type in all you have to do is just enable Cilium with the multicast and just type in those data, single command that you can use as a multicast. Because so we don't want to limit the use case. So even though we don't use multicast basically, I think there could be some use cases to use multicast. For example, general DDS and ROS2, and also there could be some use cases. So now the Cilium can actually support a multicast-based discovery in the application layer connectivity, if you want to use. Yeah, and I don't know any other CLI implementation that support multicast. As far as I know, only the Cilium you can enable, but default is off.
And I understand why. Indeed, you are right. I'm just having all the time this issue that somehow you have the robot on one end and you would like to have multiple services listening to the same stream, but there's no good way to get it to multiple nodes. Thank you for answering. I leave the to the next questions.
Yeah. Any other questions?
It looks like the raise hand queue is empty, so I'm going to go ahead and not raise my hand to ask my question. I was going to say, so you've talked about CubeEdge and how it can be used, but are you using this as an over-the-air update mechanism for Sony or anywhere else?
You mean the question is, do we use it in production?
Yes, exactly.
Not right now. We are working on that. Yeah, I mean, like there is some ongoing the projects, but I can't disclose those informations. But we are working on it because that's the whole reason that why we R&D that work on this kind of solution.
Got it. And is there something that's missing from CubeEdge? So features you've yet to add, or is that just it takes time to put things into production?
We have actually fixed the couple of not a couple of a bunch of issues to enable Cilium because that was pain, but now it's been fixed. So the next step is the question is, can we actually use resource constrained environment? And I would say yes, but we didn't get there. I mean, to use actual device for the production to see what's going to happen. So that's exactly I'm interested in and what we are going to do. So if we find out, oh, this is not well optimized, or off the top of my head, CubeEdge provides many features, but I think it depends on the application requirements. What kind of feature should be enabled? So maybe there should be some mechanism to enable, disable, and configure the specific features that only required to the business logics. So that's kind of configuration feature could be useful, I think. Yeah.
Got it. So essentially, you believe it's production ready, but until you try it for real, it could all go up in flames.
Yeah, actually, the CubeEdge itself is I think it goes everywhere already.
Mm-hmm.
Like a traffic control devices, some the payment at the parking, these or vending machines. So all these use cases they have already deployed millions of CubeEdge use cases.
That's really cool.
So as a CubeEdge, I think it's already production ready because they already have, and the CubeEdge is already the graduation project by the CNCF. That means the production is pretty much ready. Yeah.
Great, thank you. That's my question done, and thank you for the talk. See, we have a new hand.
Still the same hand. Tomoya, I tried to play with the CubeEdge a couple of times, but does it with your with Cilium now? You don't require this submariner anymore now to do the.
No.
Okay, so and then what are the So the requirements is Cilium on both clusters, and then I imagine the cloud cluster needs to have a public endpoint for the WireGuard to connect to, right? And
Yeah.
that's it.
That's it.
Okay, I'm going to
Yeah.
try it. I'm really
So
really curious.
we have many types of this. Like what we do is it's really easy. Using the Terraform to construct some cloud instances, and then some like public IP address assigned Elastic IP. We do use AWS or public cloud, but the Elastic IP is assigned to the Kubernetes cluster, and then the Kubernetes can connect using MTLS, and the cluster is ready. That's the control plane. And then what we do is enable Cilium. So the Cilium knows using control plane where to access the master server, and that's going to connect to the using WireGuard. That's going to inject the WireGuard configuration into the Linux kernel, and then try to connect the punch hole, the like a tunneling using WireGuard VPN to the server.
And that's for the control plane. And then the CNI within it with Cilium also routes the data plane then.
No. The controller plane doesn't use the WireGuard by
Kubernetes. Okay. So only the data plane. Okay.
Yeah, only Cilium. So Cilium asks you like, do you want to using a VPN or encryption? And if you say yes, the Cilium goes to access the Kubernetes API server to collect the node data. Because because it's already in the cluster, and the API server knows that where this edge. It actually does know the where exactly running, but the Kubernetes API server has all this information because they already have joined the cluster. And then Cilium calls this in-cluster config to collect these data and figure it out where to access using WireGuard, and inject those configuration to the WireGuard, and the WireGuard connects to punch hole the VPN to the API server, so they can be connected as data plane.
Nice.
Yeah.
And it works seamlessly with DDS now. I mean, even though IPs might change dynamically, because this was, and I remember back in the days, was also one of the somehow issues talking to Jaime from Eproxima that the IPs were changing and DDS was not really playing nicely with it. You have no troubles with that now?
So that's really good situation. So so the IP address is if we use the WireGuard or the Kubernetes cluster, IP address is assigned by the Kubernetes or Cilium, right? That
so
is
the virtual IPs, you mean?
Virtualized IP. So
yeah.
if you it doesn't matter because it's already virtualized and concealed.
Virtualized IPs, but those change if you redeploy the pods, right? So, or if they are migrated in theory, the virtual IPs.
Yeah, I mean, like if you want to deploy, like for example, the pod is running on node A, and if you want to redeploy those pods to the node B, maybe the virtualized address is going to be changed. But this is known situation in the, I mean, like in the cloud, right?
Because in the cloud, yes, but DDS usually didn't like these things. So I don't know if now it's working better.
Yeah. So as far as I can tell, we have never tried that specific use case yet, but I think it should be working. Yeah.
Okay. This is a thing because we do turn on and off things quite often with the students, and that would be an issue that I have to try it. I will really take some time.
I don't find any difficulties to why they can't work. I don't think of any reason.
They should just rediscover themselves, right? I mean, in the end, you change IP, you're still a publisher or a subscriber. You just re-advertise, so it should work.
It should work. Yeah. Yeah. So that's pretty much of it. So the presentation concludes that we are excited to this solution. I think, I mean, like open source perspective. So there are some like professional services. For example, like SUSE, Rancher, they provide a professional service, something like this. Red Hat provides OpenShift and Microshift, something like this. So that's fine, but our approach is to go with mainline. Mainline by here is the Kubernetes, and Cilium, and we're gonna work together and make it happen. And once we can make it, I think that this is gonna be really interesting because all we have to do as an infrastructure, everything comes down to the infrastructure, and all we have to do is just provision the device. And once it's provisioned, we can have full management, full observability using Cilium. And also, I didn't mention that, but if we use Cilium, we have security runtime enforcement. So that's really critical feature for the robotics. For example, like if the specific node in the specific node, the specific container and the binary is updated, we can detect that right away using Cilium because they use eBPF to monitor that specific application file system or something. So that's really efficient, and the critical application can be secured. So that's something I love with Cilium. And if we do that, I think we can, like address this cloud native based solution to edge devices that requires Linux system, right? So the only question that I have is how we want to reach out to the Leaf devices, which is non-Linux device, for example, QNX or NetX. So that's something I'm really interested in. I think something we can do is using web assembly and connect all these Leaf devices to the cluster too. But I didn't consider pretty much yet. I think I need to study more about web application and web assembly host system interfaces. But if we can do that, we can have almost entire fleet management, edge servers and edge devices, Linux devices, and also the far leaf devices. For example, QNX, NetX, this kind of like microcontroller based system. That's the maybe the 2-3 years plan that I need to have. I think that's it. Actually the ROSCON 2024. I didn't have any presentation about Kubernetes and ROS, but I did meet a bunch of people. They are asking me about this activity. So and some companies, they say they want to try. So I think we can work together as an open source collaboration to see if what's going to happen if we actually do this into production or something. Yeah.
Great, thank you. I think
thank you.
If there's any more questions, please feel free to interrupt or go ahead. Otherwise, we have, the whole session is dedicated to this, but I know, Tomoya, you mentioned being interested in some of the stuff that the working group was doing, or what we discovered in the State of Cloud Robotics or something. Is that right? And did you have any questions?
No, I think I'm okay for now.
I put you on the spot there.
We will need to add Tomoya's a link to Tomoya's repositories in the resources if we haven't done it yet.
I think we have it already, actually.
I don't remember. I didn't check. Sorry.
I can check very quickly.
Yeah, so I'm interested in the problems. For example, like what's going to happen if we do this, or can we support this configuration or something like this? I'm really interested in the problem. I'm an engineer, so if you have any concerns or problems,
I have another question in reality now that you bring about problems. No, because I didn't participate in the last meeting of this working group, but they tried out Xeno. So now, how would you change? What do you need to change anything now with Cilium if you wanted to use Xeno? because there's two ways, right? There's router communication. You have to use a router to put nodes together or to make nodes discover each other, or there's peer-to-peer. But I guess peer-to-peer is also based in multicast, and multicast across nodes in a Kubernetes cluster is typically disabled, right? So you would have to somehow build the ROS overlay topology on top of the cluster overlay to have ROS messages routed. Am I right?
Yeah,
Does it make sense?
Yeah.
So then,
go ahead.
Yeah. So then the answer is we would have on top of Cilium, we would have to basically build the router topology, the Xeno router topology.
No, you don't have to do that if you use the Cilium.
Because there's multicast.
Yeah, that's exactly why the container network interface is there. I mean, it provides the VPN. So if the cluster is ready, that means you already have the secure connection to the data plane. So that's exactly why I trying to address this issue, this specific proxy or bridge issue, because we don't want to have any bridge or proxy that is specified to the framework. For example, the Xeno router or a DDS router, we don't want to have it. That should be concealed in the container implementation. So I'm saying if we have established this architecture that I explained using Cilium, Kubernetes, whatever it is, and enabled by VPN, you don't need to use any bridge at all. That your connectivity is already secured and guaranteed. That's exactly why. All you have to do is develop the ROS application and deploy anywhere you want, and it should be connected. It doesn't matter if you deploy the cluster, cloud, or the edge. It can be connected. There is a question: do you really want to deploy like the application requires high bandwidth between cloud and edge? Probably no, but that's something you want to configure, right? If that's the like a small data packet, like using MQTT, that's just fine. Just deploy your ROS application in the cloud, and you can deploy the ROS application at the edge, but it's done. It's connected using WireGuard VPN. It doesn't require any extra task. It's secured and connected without any bridge, both way.
Gotcha. Thank you.
Yeah.
I think that's actually a really nice point to finish on as well, because something I was going to say is one thing we found both through both through the technologies that we've been looking at and from the State of Cloud Robotics survey is that people are struggling with connectivity.
Yes, exactly. That's the problem, and I see that some people trying to address that connectivity issue from the application. And I don't like that, because if that's network issue, should be addressed by the network, and then it's been solved with this solution.
So the container is agnostic as to how it's being connected to other containers. It just has a connection.
Exactly, and it's actually abstracted by the CNI, container network interfaces. So the application doesn't really know what connectivity that is bounded. It's based on your requirement. If you want to isolate this container on the host network interfaces, that you can choose. And also, if you want to connect this ROS application to some ROS application running in the cloud over the internet, that you can do. So it's just your requirement. It's so flexible without any bridge and the proxy.
That makes sense. I think, Christian, I can see your mouth moving, but no sound.
Indeed, thank you. Very observant. I was going to ask about this. So the issue with deployed robots in the field is they just lose connection, right? So one big issue is often reconnect logic. So when you reconnect, you have to typically bring into sync again the state of the world as the cloud sees it and as the robot sees it, because it's possible that the robot missed messages or it sent messages, but they didn't go through. So this is where QoS comes in MQTT, for instance, right? The quality of service where it guarantees delivery and so forth. So that's one issue that I would like to understand how that is handled here. What's something that is cloud native in the sense that it usually assumes that servers don't go down. The second one is swapping interfaces, right? So a robot can be on Wi-Fi, then it moves a little bit and it comes back online on LTE with a different IP. Can you speak to that? Would these things be handled?
So the first the problem is the control plane is if you use KubeEdge, that should be okay because the KubeEdge is the components running in the cloud core that is always running in the cloud infrastructure that connect synchronized with API server. And if the control plane goes offline, edge device usually if you use Kubernetes, there will be node eviction because the Kubernetes guarantees to redeploy some application which is gone to somewhere else, right? But if you use KubeEdge, it doesn't happen because of the edge autonomy. So the edge node understands, okay, I am now disconnected to the control plane, but I will make sure those applications running at the edge until that's something you can configure until the connection comes back online. And then 5 minutes later, the control plane reconnected. And if something configuration has been changed to the cloud, the API server, that is cached into the cloud core, and they push it down, push the data, new configuration to the edge system. So it's the low latency to resynchronize to the up to date the configuration to the cluster. Did I answer your question?
Yeah,
and
thank you.
And for data plane, that depends on what kind of like framework inside a container that you want to use. Obviously, the DDS provides QoS. That is pretty good. This kind of like a lossy network problems, I think. But it's really up to the application specific the transport layer.
Okay.
And
thanks.
yeah. And second question, yeah, I'm really interested in second question. That's the situation that we would have. So if we have some robots at the home network, and then take this robot, go outside and LTE connection, and your question is what's going to happen, right? I think it should be okay if using KubeEdge because they have some dedicated feature for this use case. That's exactly a use case for the KubeEdge, but we don't have, we haven't verified it. So that's something I want to allocate my time to see if that actually works. If the device IP address and network changes at the runtime.
I think WireGuard should fix it by itself. No, you even have the same IP after you connect on a different network interface.
Yeah, not only for WireGuard, but I think the control plane, different IP address, right, for the cluster. So there might be some problem, not the data plane, but the control plane, because the class information should be applied because the IP address has been changed. So, but that's a really good question. We have use cases exactly like that. So we will try to confirm and verify. Yeah.
So we've just got a few minutes left. I wanted to ask you as a kind of final question, if someone wants to try KubeEdge with or without Cilium and wanted to provide feedback, do you have a good way to do that? Would that be the GitHub issues or another way?
Yeah, so especially if you're running ROS application with KubeEdge or Kubernetes, you can just create issue on this the project, the ROS K8s. Yeah, that would do. But if your question is the general question about KubeEdge or Kubernetes, maybe you can visit CNCF project.
Great. Yeah. There you go. Anyone who chooses to give it a go. I also had a request during the meeting. If there's anyone who wants to help out with the working group, our meetings are open. Please come along and have a talk to us and see what we're up to. We'll also put a summary in our meetings page. And I also wanted to say as one last point that next meeting is not on, so we meet bi-weekly. Our next meeting would be late December. I'm not sure of the exact date. the 30th. So we're not going to be doing that. That's over the Christmas period. So the next meeting will be on the 13th of January. We currently don't have anything planned. It will be a general catch up. So yeah, if you're interested, that would be a good time to come along, see what we're up to and how you can contribute. So with that, I want to thank you again, Tomoya, for joining us and talking about CubeEdge and Celium, and for everyone who came to have a listen. I think we have about 2 minutes left before the call ends for us. So if anyone has any burning last questions, you can just about fit them in.
Yeah, thank you very much for your time, and yeah, appreciate it.
Thank you.
Okay, I think there's no burning last questions. So let's jump off the call.
Thank you. Bye. Have a good day.
Have a good Christmas.
Thank you.
Bye-bye.